Hi, and thank you for coming to my virtual poster presentation at the 2022 NASA Exploration Science Forum. My name is Jared Longfox. I am the Chief Scientist of the Class XLF Lab at the University of Central Florida. This work compares the shear strength of lunar regolith simulants designed for large-scale testing applications. The fundamental motivation behind this study is that the mineralogy of a regolith simulant dictates its physical properties. This means that studies performed with inappropriate simulants will give inaccurate results. And since NASA and others worldwide are interested in setting up base at the lunar South Pole, which is expected to be of Highlands composition, we need to understand the geotechnical properties of mineralogically accurate lunar Highlands analog material for testing and development of technologies here on Earth. One of the main geotechnical parameters that quantifies how regolith and its simulants behave is the shear strength, and specifically the Mohr-Coulomb parameters of cohesion and angle of internal friction. This study compares the shear strength of XLF Labs LHS-1 Lunar Highland simulant to a simplified version called LHS-1 bulk that is only different from LHS-1 by the less than 1 weight percent difference in composition, shown in the table in the middle of this poster. This small difference in mineralogy is expected to yield no significant differences in physical properties, but make the product cheaper and faster to produce in bulk. We used the direct shear test, and those data were analyzed via linear regression following the Mohr-Coulomb failure criterion, the equation for which can be seen in the lower left methods portion of the poster. The means of these shear strengths at different normal loads were compared using either the Mann-Whitney U-test or the t-test. The Mann-Whitney U-test and the t-test both compare means, but the t-test comes with several assumptions that need to be checked with other statistical tests, namely normally distributed data and homogeneity of variance. But the Mann-Whitney U-test doesn't make any of these assumptions, but is a bit less strong of a statistical test. We see the results of the Mohr-Coulomb regression in Table 1 in the lower middle portion of the poster, and they're overlapping 95% confidence intervals. All statistical testing here was done with a significance level of 0.05. That's alpha equals 0.05. The results are shown in Table 2 here with entries that violate the assumptions of the t-test or are significantly different given in bold. After all these analyses, we see that none of the shear strength levels are significantly different between LHS-1 and LHS-1 bulk, indicating that LHS-1 bulk is an appropriate and cost-effective alternative to LHS-1 in large-scale mechanical studies, such as regolith bins that you might test a rover in. If you have any more questions or want more information, please don't hesitate to reach out. I've put my info on the right side of this slide.